Hi, this is what a parallel circuit is. It gets a little bit more complicated. Let me add my pen in here and we'll get thinking about this. So we get to ponder how this works a little bit more. So whatever voltage is coming out of the battery is going to run through the resistor. So we're still thinking 10 volts here, okay? And we are also thinking the same energy is going to go through resistor 2. Okay? So we have a different amount of water going through, which would be thinking of your current, the Y of the river, but both parts of the river have the same energy, that same voltage potential going through it. Okay, it's kind of hard to get your thinking around it. So what happens is we have the same voltage being used up in resistor 1 and going back as empty, essentially, to the battery. And the same thing happens in the second loop of the circuit. And since there are two loops to the circuit, that is called a parallel circuit. Two things lined up in place sort of thing. So you learn more about parallel in math as well. So what do we do with thinking about this? Well, we know that the total current gets broken off into a junction, the Y, and some of it will go in as current 1 and the other part of it goes as current 2. Some of the water going off in one direction and some going off in the other direction. So what do we have? We have current total equals current 1 plus current 2. Okay, so we can calculate these things. What do we have? Current 1. What do we know that is? If we know V equals IR, then I will equal V per R. So I1 is going to be V1 per R1. And what do we have there? Well, we've got 10 volts all over 1 ohm. So you have 10 amps. Okay. Now what do we have for current 2? Current 2 will equal V2, which is still 10 volts, over resistor 2. And that will be 10 volts divided by 2 ohms, which will give you your 5 amps. Okay, so what is your total current? It's going to be current 1 plus current 2, which will equal 10 amps plus 5 amps, which equals 15 amps. Okay, so that's your current total. You have 10 amps of it will go through resistor 1 and 5 amps of it would go through resistor 2. Okay, so we can also calculate the current total in a totally different way. You can figure out the total resistance on this. So let me erase this. I know, sorry, but we'll cover at least a reasonable amount of thinking on this. Oop, we're almost done. Thanks for being patient on it. Okay, there, we're getting awfully close. So we can think about how to add up your resistors instead. So what can we do? We can look at this right here. Current total equals I1 plus I2. So what can we think of? Oh, we can use this formula. So current equals voltage over resistance. So current total is voltage total all over resistor total. And you'd have to calculate the total resistance of the circuit. And then we have voltage 1 all over R1 plus voltage 2 all over R2. And this is pretty hard math, and that's okay. We'll get there. Now, do you remember that whatever voltage comes from the battery gets used up and spent through the resistor in the first loop, and that same amount of voltage gets used up around through the second loop? So V total is the same as V1, which is the same as V2. So then we could say V total all over R total equals V total again all over R1 plus V total all over R2. Okay? And since this is the same amount on everything, we can just get rid of it. Okay, you'll learn about that later in math. Do not worry if you're like, what's going on, Trudy? So now what do we have? R total, 1 over R total equals 1 over R1 plus 1 over R2. So when we had a series circuit, your resistance total would have equaled R1 plus R2. It's just additive, whatever resistors are in the loop, you add them up. Okay? In this case, you add them up as sort of a fraction format. Okay? So what you end up doing, when we rearrange this, you actually get a nice little formula. If we do a whole bunch of rearranging, R total would equal R1 times R2 all over R1 plus R2, if we did all the math to do with that. And so your total resistance would be 1 ohm times 2 ohms all over 1 ohm plus 2 ohms, which would be 2 over 3. Okay, so 2/3 ohms. So it definitely changes the resistance when things are in parallel. Okay, so it just gives you a little sense of it. I don't expect you to handle this math at this point. This is high school math. It really is. So I like you to just sort of think a little bit about how this works, that the current gets split off, just like water, a fork in the river sort of thing. But the energy part of it, the voltage, stays the same going to either part of the fork. And then if you have to add up the resistances, it's different. In a series, it's really simple. You add them up. If it's in parallel, you have to do it in this fraction way. So if you sort of take that little bit away from this, fantastic. If you get the math, bonus, but I really don't expect you to get the math at this point. So if you really want to do some questions to this level, I'm going to send you some homework that way. You can play with it and see how you do with it. This is pretty heavy duty thinking though, so take some time. If you just get sort of the general concepts of what's going on in an electric circuit, that's really good because you will see it again at some point if you do more of it. So I hope that helps a little bit.